Okay. So to kind of start at, so the clear one is your base plate, and we don't height at all because you go down and you tear out. So when you go down, you'll hear it beep. Okay, now it's teared out. So the 0, 0. Now you raise it up.
Oh, yeah.
Mm-hmm.
And you can see that the numbers are moving as it's coming up.
Mm-hmm. Yep.
Oh, yeah.
Yeah.
Okay. Then let me grab a specimen here. Okay. Then it's really important to set the specimen on right lined up within that circle that's drawn on the surface plate. Now I always just rub off the specimen real gently just on my pants leg just to make sure there's no detritus on there.
That sounds like a PhD word there, Joe.
And so then just
We call that dirt in where I come from, but
okay, so now I'm really well centered, and the thing is this is necessary to make sure you're always keeping things repeatable. Even
So, did you put the specimen on top of the transparent disc, or
correct?
Did you... Okay.
Correct, because I found we went as small as 1 inch in diameter, but that was too small. The specimen was too tippy. But what we're doing is we're putting the glass base right at the geometric center of the specimen. And by doing that, just this little area, then I just got to make sure this area is free of any grit or, fines. And it's less likely to be that there's an aggregate sticking up. And I've played around with this a lot so that by being in the geometric center, then, like if this edge is, let's say, higher than this edge, we have to measure directly across from each other to get the average, which is the center of it. So that's why we even at one point when we were trying to use calipers, we had set up made a disc with exactly a notch at exactly 90 degrees around the perimeter so that we were truly measuring directly across from each spot with a caliper. But we were still ended up dying. Kyle and I had played around with this one day, and we were getting like a couple of meters apart, or millimeters apart. Meters would be a lot. A couple of millimeters apart. So then we also have, these are ones that I've experimented with by having, we made measurements and around the edge, and then we put the disc in the middle. When you averaged all these out, that disc gave you the number, the same number. So it's a lot quicker. So here with this disc, now in the middle, as best as I can eyeball, now I'm in the center of the specimen. Now when I go back down, this height gauge, this is a touch probe sensor. So when that moves, there's actually just a battery inside of here on a spring. When that battery makes contact, it sends a signal through the line, and that immediately stops the measurement. So again, you get more repeatability than everybody kind of, I think I'm touching now. I think I'm touching now. And so by doing that, now what is important, we found, is as you get close to the disc, you want to slow way down. Because it does, remember, that's still a signal, even though it's a fraction of a second. Somebody that goes quicker with touching the probe down and getting the beep will get a little bit different of a reading. Again, we're chasing sub-millimeters. For most types of testing, that wouldn't matter. But for this, it does.
sounds like you already got it recorded there on your end. Not yours, Joe, on their end.
Okay, so now you go
right?
Yeah.
Okay.
real slow. And actually what I'll do is I'll show this display.
129 point, I don't know, 128, 127.
Boom.
22.95.
122.95. So now I can lift back up. It'll just change as I go up. Come back down.
So, Joe, basically when it makes the beep, if I continue like rotating it, the number would decrease, right? It's not
Nope.
like the
Once
number.
it beeps, it locks that number in. So that's why another reason to go with the touch probe. So you want to be going real slow, but you know, we all react differently. So if you go a little bit further, like a half a millimeter or something, it won't change. So when you hear that beep, it's locked that dimension in. So like here, touch.
We're looking for 122.95.
122.6. Oh man, that's 100th difference.
That's pretty good, Joe.
So now, if I'm gonna just a little bit further. See how the number changing?
Two numbers, 120, 147, and 120, 146. So
wow.
it's
all right.
pretty accurate.
This, with a lot of different experimenting, is the most accurate yet reasonably priced and repeatable setup that we could find. So, any questions?
We just Oh yeah, it's very repeatable.
Okay.
So now, what you would write down is you'd write this number down, 122.95, and then you deduct off this 6.56. That's the thickness of your glass plate. That's then your pill height or puck height. So we tear it out at the bottom one.
Change. 2, 3,
So we tear, touching this one.
the thickness.
We'll go through it again. So we tear out. Then see that the number's changing.
And
The other
and
thing
the
you wanna
purpose of that bottom plate is to make sure you're consistent with if there's any sort of a loose aggregate or something.
Correct. So
yeah.
again, even because I set it on the counter here, and you can see here that there's some stuff laying, just to make sure I didn't pick that up before I go to here. Rub it on my pants a little bit, then place it right on that center, which that is the smallest diameter that was still stable with a pill sitting on it that I could get. And it also then puts your measuring at the geometric center of this pill.
And that thickness doesn't need to be taken into account because like Joe said, that's where you're setting your 0 point when you tear it out.
It's like putting a pan on a balance, tearing it out. Then all you're doing is weighing whatever you put in that pan. Now we put our back on. And this is a special glass. It's I forget what it starts with a B. But it's supposed to be very flat and very scratch resistant. Or bormite or something. I don't know. I can't remember now. I'd have to look it up. So now I'm coming back down. Make sure I slow down.
This time is without this. Same.
122.96.
Wow.
And that's going back through the process and everything. So
we got 122.95, 122.96, and 122.96. That's pretty good.
And then again, you'd write that number down and then your pill height is that 122.96 or 5 minus this 6.56. And then now you have your overall pill height. Any questions?
Does measurement around the edges matters or?
Nope, because again, if you ran around this edge, and you make sure that you measure exact. So if you do a 3-point measurement, it can really matter who picks a spot to measure in case your gyro is a little bit slanted. So, and like I say, most tests, Rice test, not that big a deal what they do in the field. But for this, we also were using this to check that the gyros, and we've seen that the gyros are really accurate. What they give is an overall height. The issue with going around the edge and doing measurements is that each person who does it, depending upon where they place the caliper, might have different measurements. And again, we're chasing sub-millimeter. We're chasing 0.1 millimeter that we're after. So it becomes super critical. The other thing with going around the edge is you have the chance of putting a caliper into a void or into a groove or into something that's, like this one's a little bit. So if I pick right in here and I'm not very experienced, I'm going to get a lower measurement than I am right here where there's an aggregate. So going around the perimeter and measuring, the only way that does work is works better is we set up a plate that is at true 90 degrees, then put that on here, marked that, then roll east, west, south, north. That way then when we took our measurements, this measurement is exactly opposite of this measurement. This measurement is exactly opposite of this measurement. So with a 4-point measurement, if they're lined up properly, what you're doing is you're taking this dimension plus this dimension divided by 2. That's giving you the very center of the pill. Same thing here. Now, this works because these gyros are, very flat. And they really shouldn't even have a slant to them if the gyro is properly calibrated and running properly. But if they do, we deal with that. Now, on a cut surface, not going to work quite so well because some people, when they're cutting, I've seen they'll kind of hollow out in the middle, so I wouldn't say that this is true on a cut surface, but on a gyro surface that is good and flat, this point right here is just the average of wherever you measure, if you do them exactly opposite of each other, wherever that is, as long as they're exactly opposite, you're getting the average, which is this point right here. So by putting the glass plate right here and measuring, you're getting the geometric dead center. Because if you notice, when the probe comes down, and that's why it's so important to set up, it is important to make sure you're keeping everything in the lines. When the probe comes down, this base, the height gauge itself, is actually set up so that the probe touches in the center of that glass disc. So it makes contact at our 122.95. So it's making contact at the geometric center of this pill, which is the average of all opposing perimeter dimensions.
And I guess from oh man, that's not going to show up well. Can you see that at all?
Yeah.
Yeah.
So basically from where the signal is actually going to be spending most of its time when we're getting our thickness, basically our velocity measurement. So we're getting this dimension here, which is the thickness of the puck. And the way the wave travels when it's sent and received by the specimen, it's going to want to minimize its time in the slowest medium, which in our case is that puck sample because it has a higher dielectric. So really most of the wave's path is going to be towards the center of the specimen. So getting the thickness in the center of the specimen actually is the best case scenario anyway for our for what the wave actually sees when we're doing our characterization. So it works out well, you know, from that point of view too. If there was a discrepancy between the center of the specimen and the outside.